Good morning, good afternoon, everybody. Thank you for joining today's third iteration of acoustic imaging webinars, more than just compressed air. Um, Again, Adam St. Clair and Justin Sheard will be going over acoustic imaging, unique applications, and some new features to our product. So definitely thank you guys for joining. Please feel free to use the chat box. This is for you to kind of get all the information that you need about this product, and if you like to speak to a sales specialist, please raise your hand at any time, and we'll get somebody in contact with you. So again, Adam St. Clair, our category manager, and Justin Sheard, our application engineer, will go ahead and kick this off for you. I appreciate everybody joining.
Dustin, thanks for the introduction. My name's Adam, and Justin is along with me. Say good morning to the folks on the line, Justin.
Good morning, good afternoon.
I appreciate you joining, Justin. I invited Justin along because he's been really involved with the production of this tool, and he's a application engineer for our team for all of the imaging technology with Fluke, but has spent a significant amount of time understanding acoustic imaging and working with our customers. So I wanted to make sure that his voice was heard today, and so he could provide you with some of the insights and perspective that he's gleaned over the years with this technology in particular. So thanks, Justin.
Yeah, happy to be here.
So I'm not sure if we're having technical difficulties, but Adam and Justin, you guys are both on mute.
Can you hear me now, Dustin?
Yep, there we go.
All right. Sorry about that. So here's just a quick peek at what we're gonna talk about today. We'll start with what acoustic imaging is and give you an overview of the technology and understand kind of how it's being used and what it's capable of. And then we'll dive into briefly how to use the Fluke i900. So get specific kind of on the operation of the tool, and then talk about energy savings and how the tool is being used to help customers save money on their energy bills. And then where we're going to spend most of the time is getting into how to build an ROI for your facility, and then also how to use what's called leak queue mode on the ii900. It's a new feature that we came out with through a firmware upgrade that we want to get you all comfortable with how to use the mode to not only estimate the kind of the monetary value, or to estimate the size or the cost of a leak, but also to help prioritize which leaks get fixed based on the findings in leak queue mode. So that's where we're headed. As Dustin mentioned, please do engage in the chat box. When you have a question, just pop it in the chat box. We'll answer them at the end. But as you think of questions as we go through different parts of the presentation here, just pop them in there, and then Dustin will field those at the end. All right, so what is acoustic imaging? Essentially, it is a tool that visualizes sound. So it visualizes sound between 2 and 52 kilohertz. So it actually can see or visualize things that we can't hear. The human ear can hear sounds between 2 and about 5 kilohertz. And so we're able to go well above that, up into that 52 kilohertz range, and visualize sounds that we can't hear with our ears, as well as things that we can hear in normal environments, but maybe are masked by a lot of the ambient noise in a facility. So essentially what the technology is doing is it's overlaying the sound map onto a visible light image. So you've got an array of 64 microphones on the sensor head on the front of the tool, and in the center of the sensor head is a visible light camera. And what it's doing is it's listening for all the sounds within a field of view, and then overlaying them within the frequency band that you've decided to visualize, or that you've identified to visualize. Essentially, this tool was designed for visualizing compressed air, gas, and vacuum leaks. Although if you've joined webinars in the past few weeks, you saw a lot of different examples of different applications. But the primary application, at least when we developed the tool, was for compressed air and vacuum leaks. And we'll get into quite a bit of that here in a little bit. So just to give you an idea of the form factor and the size of the tool and how it's used, this is just a quick video of Justin here actually taking the tool out of the box, setting it to image capture mode, and then scanning an area. So it's literally that easy. You turn it on, you scan an area, what you're looking at with your eyes or what you're pointing the tool at shows up on the screen, and then where you see those targets there pop up, that's an area where you've identified a leak and that you can go and either fix or investigate a little bit further. That's just a peek at the form factor and how it's used. Now we'll zoom in to the screen and give you just a quick idea on kind of the mode of operation here. So on the left-hand side of the screen, you've got all of the different menu options where it says image there. That allows you to toggle between capturing images or videos. So you can capture up to 1,000 images on board the internal storage memory, or you can capture videos as well, up to 5 minutes of video. I haven't seen anybody capture a 5-minute video. Usually they're quite a bit quicker than that. But still, that video mode can be really helpful, especially when you have a compressed air system or compressed gas system that works intermittently. So it's not just steady flow; it's got flow that's pulsing as part of a production process or enabling some other process. And then you've got the memory. This allows you to just onboard the tool, access all of the different images or videos that you've captured to either review later or to show somebody else. So you've got that onboard memory. Acoustics, the option there just allows you to fine tune the way that the acoustic settings are set for the microphone array, and that will just allow you to dial into a specific type of sound that you're looking for, or type of leak that you're looking for. And once you've got a pretty good idea of the leaks within your facility and the characteristics of those, you can use that acoustic setting to fine tune the instrument. Palette is simply just changing the colors that display for visualizing sound. Markers is that decibel reading right in the center of the screen that you see there, which is actually giving you kind of the amplitude of the sounds that are within the screen or within the field of view. And then the settings is pretty basic stuff, just changing time, date, language if you need to, and just kind of the basics there. So that's the left-hand side of the screen. On the right-hand side, you see both the amplitude spectrum and the frequency scale. So the amplitude spectrum, that gives you an idea for the amplitude of the sound within the field of view, and what color is representing what amplitude level, so or what level of amplitude. And then to the right of that, you've got the frequency range, like we've mentioned already, 2 to 52 kilohertz. But what's cool about the tool here is you've got that yellow box that's set at the top. Right now, set between 30 and 50 kilohertz. That box is manipulatable, so you can shrink it down to hone in on a smaller frequency range, or you can also adjust the level of that banding to ignore or omit different sounds from different frequency ranges that you want to ignore. So that's particularly useful in really loud or noisy environments where you've got a lot of rotating equipment, or you've got a lot of processes happening around you that emit a lot of noise. You can adjust the frequency range to eliminate all of that noise and really hone in on the specific area where you would find a compressed air, gas, or vacuum leak. So that's the tool and how it's used. As I mentioned, the primary application that the tool was developed for was for compressed air. So our customers were telling us, hey, there's a lot of opportunity to improve on the way that this is done. We heard customers telling us that they would do something called snake hunting, or just they would when they had a planned shutdown, they would send a group or a team of folks around and literally walking their entire compressed air infrastructure, listening for hisses. And obviously this couldn't be done while production was running because of the ambient noise. But that was something that was done because of all of the energy waste or all of the impact on quality to their production process because of compressed air leaks. So they would send somebody or a group of folks along that infrastructure to identify where the opportunities to make fixes are. The other thing or method for finding leaks that our customers were telling us they used that they wanted a better solution for was soapy water. So I'm sure, I know I've done it looking for a leak in my car, or at least I used to. But you can fill up a water bottle full of water and soap, and you can spray all of the different joints or fittings or couplings, and when you've got bubbles coming back, that's because of the positive pressure coming from a leak. Extremely time consuming is what we were told from our customers. Is you would literally have to go and spray everywhere that there's a potential leak, sit and wait and see if it bubbles, and just being able to do that with any kind of scale is nearly impossible. So it was used as a troubleshooting method, but not really as a preventive maintenance or a cost savings method, just because of the time it would take to do it. And then the other thing that our customers were doing was using ultrasonic leak detectors. You've got the picture in the bottom right-hand corner. That's probably something similar to you all have seen, where it would be a device that's doing something very similar, that's listening for ultrasounds or sonic sound waves, and you've got the headphones. So you're listening for something very specific, and somebody that's trained on the technology and how to use it, as well as has a pretty considerable amount of in-field training or field knowledge, they would go and they would inspect areas, again, able to identify leaks. A lot easier than the soapy water, but still pretty time consuming, because you can't scan large areas really quickly, and then you would also have to change sensor heads when you're going from kind of searching or scanning a large area, hearing something that would indicate you should look further, change to a more sensitive sensor head, and then identify or pinpoint where the actual leak is. The other kind of downfall to using ultrasonic leak detection tools was our customers were saying, you know, it's expensive to have people come in and do it, and if we were going to do it in-house, it would take a lot of training to get people up to speed to where they could do it efficiently within the facility. So that's what our customers were saying they wanted a better solution for. And we asked why. Like, why is it so important that you have a solution or you have a program for compressed air? So here's just some quick facts about compressed air in the industrial environment from the Department of Energy. And I won't read off all of the statistics or the facts here. But really what it came down to is these leaks in compressed air intensive environments or compressed air intensive facilities can not only impact product quality or the operation and function of a process, but it can cost a lot of money on an energy bill, considerable. The one that stands out to me most is a single 1/8-inch leak can cost as much as $2,000 a year. You'll see later in some of the examples that we show using the leak quantification mode, it's not crazy to go out and find leaks like these in facilities. I see them all the time, and that's a single leak. So for customers that have compressed air running throughout a facility, if you identify several of these leaks in a year, the savings is pretty profound and adds up quickly. So that was really the impetus for us investing in this technology and working toward coming up with a solution for our customers to help them solve this problem. So that's where it started, and that's why the II900 was born. So let me tell you a quick story, and Justin, I'll look to you to add some more clarity or some more color here, because we worked with a local company called Genie who makes these lifts, And when we were in development and production of the concept for this tool, we worked with them to get an idea for how much power this tool had and how good and effective it was at identifying leaks throughout a compressed air intensive facility. So we went down to Genie and we hooked up a power logger on all 4 of their compressors that are used to run their manufacturing process. And we monetized the energy usage on those 4 compressors for a week before we went around and scanned for leaks and then fixed them. And then we did that same load study for a week after we identified and fixed all the leaks. And what we were able to find is that nearly $50,000 of savings was generated just from fixing the leaks on that set of compressors and compressed air infrastructure. And we recovered nearly 25% of their air capacity. And I think there was some significance there because Justin, I'll let you chime in here. Correct me if I'm wrong, but weren't they about to buy another compressor because they were getting close to capacity with the 4 they had?
Yeah, they'd already started the capital request, and they were on their way. But then when they saw that they could recover all this, they could use that 4th compressor in the expansion area. So yeah, there's the energy savings, the 50,000 per year, but then the savings from not having another compressor, maintenance costs and that compressor, and it kind of it went on and on, the benefits for them.
Yeah, thanks for that color there. So yeah, interesting. So you've got this energy savings of 50K, but then they didn't have to buy another 250 horse compressor to expand their facility. So there's some savings there. Another piece of it is just the time savings and the labor savings. We talked to one of the maintenance managers there at Genie, and he was saying with traditional methods that they used, which in their case was soapy water, as I mentioned before, he said it would take them as much as 45 minutes to go and find a leak where they suspected they had one. And now they were able to scan a large area and find that same leak in just a matter of seconds. So that labor savings or time savings is another element that our customers are saying is having a pretty significant impact.
Well, and really, while I was there, it was not that long for them to find the leaks, put it in their hands. They were able to do it quickly. They were pretty excited to do this. I think one thing that's noted on here is that they didn't have to go back up and verify with soap and water. So you can imagine how much work it is to first find the leak, then you have to fix it, and then it wasn't fixed correctly. So all of these are improved by being able to just point a camera at that in that area.
All right, let's talk now and kind of shift the conversation about building an ROI. So we talked about these specific examples where we went on site and we hooked up power loggers, we went and we found the leaks, we fixed the leaks, we rehooked up the power loggers and did that whole study and that whole process, which is great, but not feasible necessarily for everyone to go and do. And so one of the things that our customers were telling us is they were saying, hey, we need a way to create kind of an ROI estimate for our facility, in order to get the capital investment or in order to get the buy-in cross-functionally from my organization to invest in this tool that I believe in, I'm going to need a little bit of help justifying that and going back to my boss or going back to my department or my team and really communicating the value and the opportunity here to save some money. So our customers were looking to us to help them get that insight or glean that insight and be able to communicate across the organization. So we built an online ROI builder, and I just want to walk you all through how that is done, and so that you can take the learnings here, the process here, and go through and see what kind of return on investment you could have within your particular industry, given some of the input variables on site for you. So the first thing that you got to do to build this ROI for your facility is go to the website. There's a link on our website that'll allow you to pull this up, and we'll get it to you if you need it, but it's relatively easy to find when you just navigate to the product page on the Fluke website. And then you start out just by entering in a couple of basic pieces of information. What's your company name, and then your industry type. So we've got 30 different industries that are that you can select as an option, and then it will take some of the known kind of averages from those industries to help give you a more kind of tuned in ROI given the type of industry that you're in. And then you're going to select the units that you work in. So whether that's imperial, just horsepower and cubic feet per minute, or if you and your team think about things on a metric standpoint and you're looking at kilowatts and cubic meters per hour, that's an option too. It just changes kind of how the output units are displayed. And then finally, your currency symbol, which I think in this case we've got all US folks, so the $ USD there will be the standard. And then the next thing that you input is some of the operation information. Now this will be specific to your facility, your site. You're going to enter in the total installed compressor power. So that's not just your biggest compressor or a single compressor. You can go ahead here and input the total horsepower for all of the air compressors in your facility. In this specific example, a 500 horsepower compressor, you know, and Justin, from the work that you've done, I mean, where we see kind of significant savings, kind of that baseline, it's right around 250 horsepower. Is that what you've seen from the studies that you've done with customers?
Yeah, and it's pretty common to have quite a bit more than that, but even at 250 horsepower, there's going to be a significant savings enough to look into this. Yeah.
Yeah, so I'd say that just to kind of give you an idea of the baseline. Most of the time I'm seeing the total compressor horsepower higher than that. But if you're around that 250 mark as a baseline, there's going to be significant opportunity for you. And then the next input is cost per kilowatt hour. I know that at least in some states there's some variance in the cost depending upon the time. So there's peak times and non-peak times, and it costs a little bit different. I would just encourage you here to put an average, or even just go conservative and go with hey, we're gonna just pick the value for non-peak times and assume that we're just going to take a conservative approach here. And that cost per kilowatt hour, if you don't have it, it can be found on your utility bill. So it may take a phone call or an email to get access to that, but on the bill and relatively easy to find. And then you're going to want to input the operating days per week. So if you're working 5-7 days a week, whatever the case may be, that's how much the compressor is operating. So just think about the weekly cadence there. And then the hours per day. Is it a single shift? Is it double? Are you working 24 hours a day, or is the facility working 24 hours a day? That's what you're going to want to input in your operating hours. And then how many days do you at least have for planned shutdowns per year? Wanting to take that into account as well, knowing that during those days you're not going to be using any energy to run your facility because you're shut down. And then finally, the investment in the tool has also got to be, that's where the ROI comes from. So the cost of tool would be an important input. All right, the next piece is going to be providing some input to what you're doing currently. So whether that's we're not doing anything, we're doing internal things to help mitigate or identify leaks, or, and I hear this quite often, we have external people or a third party coming in and doing inspections either annually or biannually. So select which of those is true for you and for your facility. And then just add a little bit of detail around the current state. So if you're getting a third party to do it, how often are you doing that? Is it every year, every 2 years, every 5? Is it twice a year? Whatever the case may be. And then how much it costs. Typically what I've heard from customers that have a third party coming in and doing inspections annually or biannually, It costs about $1,000 a day, I would say, on average, or just north of that. About 1,200 is what I would hear normally. And for kind of a medium-sized facility, it would take those third parties between 4 and 6 days to scan the entire facility. So I put $5,000 in this estimate here. I think that's relatively conservative if you're having a third party doing it currently, but at least gives you a starting point. And then if you're doing it in-house, it's just, again, how often are you doing it? How long does it take? And then how much is the labor for getting that done? So just plugged in some generic values here, but it'll at least give us a starting point. So that'll be the next step. And then after you've input that, just those few pieces of information, this is what you're going to get back. It's going to give you an ROI sheet that breaks down all of the different inputs that you just put in there. It'll say, your name, your industry, and then it'll give you these estimates for total air capacity and airflow. Again, this is based on the inputs that you provided and the industry averages and things that we learned from all of the different research that we did within the 30 industries in the drop-down menu. It's going to take into account your energy cost and how much you're operating per year, and then it's going to give you this estimated annual cost of compressed air, and then the energy or the electricity loss due to those leaks, and then it's going to spit out the ROI as far as how much time to pay that back. So in this kind of conservative case, we've got an estimated ROI of 6 months. So I would encourage you, go in, use the tool, input just a few of those simple values and see what kind of ROI you can get. I know that especially in times like these, I know here at Fluke, we're being pressured to make the right investments, make the right choices. We're not, we haven't shut down spending. We're still continuing to invest in the business where it makes sense. But it's under kind of some scrutiny right now to make the right financial decisions. So I think this is a good tool to help ensure that an II-900 and investing in a program like this is the right place to spend the dollars, and making sure that you're going to get a positive ROI in a meaningful time frame to justify moving forward and creating this program or implementing this technology in the facility.
And I would just highlight that, you have the 500 horsepower there, that even with 500 horsepower, it's about $150,000 a year of energy. So if you can get some portion of that in savings, and the Department of Energy has clearly showed that most facilities have about a fourth of that is in loss. So there's a big opportunity.
Yeah, thanks, Justin. All right, let's transition now to using leak queue mode. So what we just went through is an ROI case or an ROI builder for a facility in a given industry, just using kind of industry averages and operational input variables input by you. And that's good to give you kind of a general idea and an overview of what you can anticipate from a savings standpoint with the tool. But what leak queue mode is it's the ability to kind of get some of that very specific information now that you have the tool in your facility for the leaks that you find. So the way that leak queue estimates is mostly empirical. It's based on average sound generated by average leaks. So we measured several different leak types at various flow rates and different pressures, and then we came up with a regression model to estimate a flow rate out of the decibel measurement being captured by the tool. And it doesn't provide flow measurements, but it does use kind of some flow calculations to estimate the severity or the cost or size of the leak. And then if you think about kind of how leak queue mode works versus traditional methods, I mean it's really just kind of the smarts or the intelligence to come up with that value is built into the tool, and it's really done automatically. So the sound generated by a leak, which is represented by the decibel level, it decreases exponentially with the distance to the point from where the measurement is taken. So by including a measurement estimation, the II-900 is compensating for the distance to get the estimation of the decibel level generated at the point of the leak. And so I'll run you through kind of how you go through the process of capturing a leak and then putting it into the online tool to quantify or estimate the leak. But that's generally how it's working and what it's doing. Justin, I know that you've been involved quite a bit in the creation of this feature and functionality. Would you add anything there for clarity?
Yeah, well, I think you talked about it, that there's not one just formula from a physics standpoint, so it's a lot of data. That empirically, that means that we're taking data, all different distances, different types of leaks, and putting that into creating a model from that. So I think you talked about it there, Adam, that it looks at the distance. I would highlight that versus other solutions here, you don't have to be at a certain distance. You don't have to know what frequency. It really captures all that data for you. So you're getting a better result than in the past.
All right, so let's go through how to actually capture an image or a leak in leak queue mode. So when we went through the menu at the beginning, I told you, hey, if you select the image button, you can select or you can pick whether to capture an image or capture a video, and the other option there is leak queue mode. If you already have an II-900, you can update your tool with a firmware upgrade that's online for free and be able to have leak queue mode. So if you have one and you're like, hey, I've already tried to switch between images and videos, and leak queue mode's not an option for me, it is. You just got to upgrade your firmware. It's available on the website. If you ordered one today, it would come with that functionality and that upgrade already built in. So essentially all you got to do is put it into leak queue mode. And leak queue mode is doing something very different than just capturing an image. An image is literally a screen capture of what you see on the screen. It's just a JPEG of what what is appearing on the screen. When you're capturing images in leak queue mode, you're capturing the visible image, what you see with your eyes, but you're also capturing all of the acoustic data that's being picked up by the tool, and that's what's being used to get plugged into the estimation tool. So you put the imager in leak queue mode, and then what you're going to see that's different than just capturing images in regular mode is you're going to see this circle pop up in the center of the screen, and you're going to also see that prompt along the top that you can see on the imager there that says no target found. So now what the II-900 is doing is it's looking for a leak, but it's looking for it in that specific area. All right, so you'll know you're in leak queue mode if you've got that circle in the center of the screen, and then you've got that display of no target found. So you do everything just the same. You scan an area, looking for a leak or looking for that target on the display, and then you've got to center that or position that leak inside that middle circle there. And then what you see at the top, once you've got a leak that's positioned in the center, it'll switch from no target found, and it'll populate these two boxes, one of them being distance and the other being leak queue scale. So the distance to the leak, as Justin was mentioning, the distance is a vital variable. If using traditional methods, if you were trying to quantify or estimate the size of leaks and your distance changed, you would get a very different output. And so the II-900 algorithms take that into account and make those offsets and adjustments for you. So if you're within about 15 feet, the imager will actually calculate the distance automatically, and it'll pop up on the screen there without having to do any manual input. If you get beyond that 15 feet, or maybe in some cases you don't have direct line of sight, so it's difficult for the imager to identify the object that you're looking at. You can manually put in that distance to give you the most accurate estimation. So within 15 feet and good line of sight, it's going to populate automatically. If you're outside of 15 feet or you don't have great line of sight, just go ahead and capture the image, and then you can manually input the distance later. So you'll want those two things to be populated, both distance and leak Q scale, which is really just looking at the decibel level of the leak at that distance within the frequency range to give you a number and give you that kind of that severity scale look. Okay, and then once you've got the leak position in the center of the screen, distance is populated, leak Q scale is populated, you press the green bar to capture and save. You want to make sure that you're holding the imager steady and still on the leak that you've identified in leak Q mode for about 1.5 seconds. It's taking a little bit of time just to capture and process all of the data. So just make sure to hold that position for 1.5 seconds. You'll see kind of a scroll bar on the bottom pop up, and then the image will show in the lower left-hand corner, and it'll say image saved. Then you know that you can move on and keep scanning and keep capturing leaks. Okay, so you've gone around the facility in leak queue mode. You've got all your leaks captured in that AS2 format with all of the data behind the pictures. And now you want to go and you want to understand how much would fixing those leaks save me, or how much would it cost? Or you want to prioritize the leaks that you found because you can't go fix them all during a shutdown, or you just don't have enough time to go and address all of them. So you want to see, hey, which one's going to go have the most impact? Now you plug it into the reporting tool to turn all of that data that you captured into some meaningful information to inform the actions that you take. So you plug the IN900 into your computer, you download the files, and then you go to the online calculator to drag and drop the images. And it's as simple as that. You've got the online calculator pulled up on half of your screen or on one screen. You open your file explorer where you downloaded all of your AS2 files, and you drag them and drop them into that little gray box on the reporting tool. And then you'll see all of those images populate on the left-hand side of the screen. And you're gonna start to quantify or estimate the leaks from the images that you've dragged into this box and into this reporting tool. Then you've got to input a little bit of information. So we need to know some of the input variables for your facility specifically. So again, you're going to kind of go through a few questions just to make sure we're giving you the best estimations possible. And most of them are pretty straightforward. I do want to highlight just a couple of things that are different, or that you can change if you have a little bit different situation, or if you've captured different types of leaks. So the first thing, the first thing I want to highlight is gas type. So right here you see gas type is selected as air. You can also select different types of gases if your facility has different gases and you've identified leaks. So maybe that's nitrogen or helium or argon, any natural gas, any other type of gas. You can put that in there, and then what you would need to do is just input the direct cost of that gas in USD per CFM. So how much does that gas cost per CFM? That's going to help you get a monetized output there. If it's air, what you're going to be monetizing is the energy costs. So you would leave the cost of the gas as zero because air doesn't cost you anything, and you would just input the electricity that it takes to take that just air, ambient air, and turn it into compressed air. So the other one, and I've got the arrow pointed at specific power there. The other one that I get a lot of questions on is, what is that specific power ratio? So really what specific power is a value that indicates the efficiency of a compressor at full capacity. So specific power is essentially the number of kilowatts a compressor needs to generate 100 CFM at 100 PSI. for most compressors on the CAGI standard spec sheets, provided by the OEMs, they will rate the specific power, so you can input it based on your findings there. But it is a relatively complex calculation. So if you don't have easy access to the specific power for your compressor or set of compressors, I would just say input a value of 30. That's what I got there. That's what it'll default to on the tool. And basically that's saying that the efficiency for your system is average. Any value around 20 is going to be an extremely efficient system, which is possible, but not likely, at least in most industrial environments. And then 35 or above, that's going to be an extremely inefficient system, and not likely as well. So if you don't know specific power, I would encourage you to just put 30. It's going to give you kind of the average efficiency system, and give you the best estimations there. Justin, anything to add on that? I know that you've been involved quite a bit here. Is 30 where you would put it? That's where I've done it.
I think that we've noticed that if you look up from a manufacturer, they're often kind of over-speccing that, maybe more in the lower numbers. So it's kind of best case. If you don't want to have it like that, then you might want to scale back to about this 30. The other thing is there's ways to calculate it over time. If you really want to know, you can kind of look at over a week or over a certain amount of time how many kilowatts you had and how much flow you've had. So you can calculate it better if you want, but I'd start with 30.
All right, awesome. Okay, so you've got your images in there. You input your facility variables or your operational variables, and here's what pops out. You're gonna get a report that outlines all of the different leaks that you found, and it aggregates them or sums them all up to give you a summary for how much those leaks are costing, the estimated cost of those leaks per year. So, and the last ROI tool that we went through, it was kind of industry specific, just kind of giving you a ballpark or a starting point, a conservative starting point for what you can anticipate in a facility like yours, but you don't have the tool and you haven't gone out and found all of your specific leaks. That's a kind of a general ROI tool that our customers were asking us for. This is very different. This is your specific facility, your specific leaks, and capturing all of those and putting them all together in a report to understand fixing what leaks is going to have the most impact and what kind of impact they could have if you go and you fix them. So the report gives you a summary of all the leaks that are listed, the cost, and it sums them up. And then below that summary page is a page for each of the leaks that you found. So it'll give you the picture. It'll also give you some of the different variables that you've either input or that the tool has captured automatically. And it'll put it all together in a report, so you could either share that with the team that's going to go out and do the fixes, or you can save it for comparison. So when you go out and you either verify or validate the fixes later, you've got kind of a pre and post fix comparison image to make sure that you've corrected the problem. So that's a look at what the output is. All right, so that's really the ROI side. What I want to do now is spend a little bit of time talking about some of the other kind of updates or upgrades that you would get from the most recent firmware release. So again, if you have an i900 already and it doesn't do these things, just go to the website, download the firmware. It will do all of these things. And this is how all of the new units are shipping today. So here's a couple of the other things that we've done to improve either the user experience or the intuitiveness of the tool. So one of the pieces of feedback that we got from our customers was, hey, I've got 5 different people at my facility that are all using the tool, and a lot of them have different settings that they want to use when they pick up the tool. And so can you guys help us make that easier? We don't want to have to rely on somebody to remember all of the different settings or how to get there in the menus. Can you make it easier for us? So we created custom profiles. You have to go in and enable the tool to be able to set profiles. That's found in the acoustic settings. But once you've done that, you can add new profiles, and you can add several different profiles on the tool, and all of the different ones that you set will pop up as options to select from. So it'll show profiles will show up on the bottom of the screen just in like a little toolbar. It'll always be there. You select that, and then you can both select an existing or create a new profile from there. And the different things that most people are adjusting in the profile settings are the frequency range. So again, like I mentioned earlier, once you've got the tool on site and you've identified several different leaks in your facility, or with the kind of the characteristics of your facility from an ambient noise perspective, you might dial in to a specific frequency range that you just know, hey, in this part of the facility, I want to set the II900 between 38 and 48 kilohertz to ignore the ambient noise and really hone in on the types of leaks that are in this part of the facility. That is likely true. And so if you want to create a profile for a person, you can do that. If you want to create a profile for a specific area of your facility, you can also do that. And it optimizes just the user's experience and ability to make sure that they've got the right settings to go out and find leaks effectively in a given area. So you can change frequency range. That's what I see the most frequently, is adjusting that and having that preset, so you don't have to remember what that specific range is in a particular part of the facility. The other thing that you can change is just adding color palettes or markers. That I don't see as much, but it is an option. Or any of those fine-tuned acoustic settings, those will all save in the profile as well. So really, it's just a quick way to toggle between settings for either different people or different areas within the facility to make sure that the tool's in the right settings to get the images or videos that you need. The next thing that our customers said that they wanted help with was how to get better, or how to be able to store these images in a more kind of logical way. So I mean, imagine all the different areas in your facility and all the different opportunities or areas where there could be leaks. You go out, I mean, it's not uncommon. I've gone out on site with customers and captured 50 different images of leaks in just one section or zone of the plant. And then you get back to the office, or you get back and you're looking in the memory at all of these different images, and it's pretty easy to forget where you were or what that picture was of. In the industrial environments that I've been in, you may think you'll remember, but it's pretty easy to get back and review the images and say, you know, where the heck was I? Or that looks like, you know, one of 50 different components that we have in this area. So what we did was we created the ability to make folders. So you can create a folder, you could call it a route, you could call it a specific area of the facility, you could call it a specific piece of equipment. You could call that folder by somebody's name, so you know who captured what images. But essentially what it does is it just allows you to create a folder, name it, and then once you've selected that folder, every subsequent image or video that you captured gets saved under that heading inside the tool. And not only does it organize the images or videos in that hierarchy within the tool, when you export or download the images from the tool onto your PC, it has that same hierarchy, so you know you can just click into the different folders to find the images that you've captured there. All right, the other change or addition is the ability to add annotations. So annotations, essentially, it's just additional information that you want to capture along with the image or video that you've captured. So there's two different options. You can add text notes, which is you know, literally just typing in some other pertinent information that you want to make sure it gets captured along with that image. Or you can add photo notes. So where I've seen photo notes used a lot is, you know, you take a picture of a leak, but it's pretty close to a particular component, and you don't have a lot of context for where in the plant or where in the facility that you are. So it can be difficult to remember where to go make the fix or where to go tell somebody that you found something. So I've seen customers use photo notes to take pictures of things, like just generally take a picture of an area where there's some sort of landmark or some sort of thing within the facility that everybody recognizes that would indicate where you're at. So again, it's just another one of those ways where you can help either yourself remember or help communicate to others where within a facility the leak that you found was. So text or photo notes, again, just to add some context and give you some opportunity to remember where you were and where to go back and make a correction.
Well, and I would add that you don't have to remember where that file is. It's all wrapped up, rolled into the one master file, which is that AS2 file. So if you put text notes or photos and you put it into the folder like we talked about earlier, it's kind of all in one place. So we're really helping save time on organization here.
Yeah, that's a good point, Justin, and it kind of sparked my memory too. All of these annotations or inputs that you add to the image or that you select to capture the image in, all of those not only get translated into just a single file for you to refer back to later, they also come through in the reports that you build. So if you added a text note or a photo note to the image, it would show up in the report that you created. So yeah, just some other ways that it's just making it useful. It'll translate all the way through from capture to export to your computer, all the way through to the report generation. All right, the last thing that we added was the ability to put tags on the images. So just again, for some of that meaningful context for the images or videos that you capture, the tags will allow you to identify the type of the leak. So if it's a threaded cap, an open end, rubber hose hole, whatever the case may be, there's a list of kind of the ones that we see most commonly to select from, just as a quick radio button, select it and it'll populate. Or you can select the other option and go ahead and just type in whatever that particular leak type is, either for you to remember or just for there to be more context for the report that you're creating to share with the broader team. You can also select the gas type. So, an argon leak is going to appear on the II900 screen the exact same as a compressed air leak or a vacuum leak is. It's going to look exactly the same. So if you go out and you scan an area or a particular part of the facility and you find air leaks, vacuum leaks, argon leaks, and natural gas leaks, having those tags can be really helpful. So when you go back and create your report, you can identify and specify the type of leak that it is to be able to get a more kind of close estimation for the cost or severity of that particular leak. And then you can input the pressure of the line. Again, if you've got multiple compressors in a facility or it steps up or steps down in a particular area, that's going to impact your quantification estimation. So having just taking a quick note of the pressure of that particular line can be helpful when taking it a step further to try and understand either estimation or prioritization of that particular leak. So
do you have to put all these things in? No, but if you input the type of leak, the air, type of gas, there are a little bit of adjustments in the model to adjust the dollar savings, like you talked about. So you don't have to do them, but they just refine it to one more level.
Optional.
Yep.
Okay, we've got about 7 minutes left, it looks like, and I want to make sure there's time for questions. So I'm just gonna breeze through some of these application examples. But I did want to give for those of you that haven't seen the II900 in action a lot yet, or you just don't have a full understanding for some of the different applications, I want to spend just a minute here. So I'll breeze through these, but hopefully this will get your wheels turning about the different places in a facility or the different types of applications that our customers are finding the technology useful. here's a quick look at a process valve control panel. The electronics were shutting down, and the customer didn't know why. There was condensation in this control panel, but they didn't know why this condensation was happening or where it was coming from. They thought there was an air leak that was creating this condensation, but they couldn't pinpoint it. They couldn't hear it. They couldn't feel it. And right away, they were able to find the area that needed to be fixed to eliminate the condensation and prevent that electrical failure or fault from happening. It's a pretty cool example. Identifying where condensation creation is coming from. So not energy savings, but still a pretty cool example. This is an automotive facility that I visited that was using traditional methods to scan all of the different airlines for the semi trucks that they were producing using soapy water and ultrasonic, depending on what part of the production line. And they're now using the II-900 because it's so much faster and it's also more effective. This particular image was of a vehicle that had just gone through inspection and passed using ultrasonic. And we went and scanned the vehicle using the II-900, found this leak right away that otherwise would have been missed. So now it's part of their quality control program, and all of the vehicles coming off the production line are getting scanned. Here's some ducting, so a vacuum leak example. This particular duct is sucking out gases from the production process within this facility. It's sucking the gases out to keep people safe. So they're unsafe gases to breathe, but they're an off gas of the production process. So having these leaks is important, or identifying these leaks was important for this customer to keep people safe, and also to avoid any potential EPA regulation issues with leaking this gas into atmosphere. Here's an example of kind of a mechanical application. So this customer was using the II-900 to identify when some of their roller bearings overhead were in need of maintenance or replacement. And the cool thing about this story is this customer in particular actually told us that they spend $4 million a year on scaffolding to have people go up in these overhead locations to inspect and identify areas that need maintenance or repair. And they were able to reduce the cost of their scaffolding bill significantly by not having to send somebody up into the air to go do these inspections and maintenance. Now they're able to identify the areas that need maintenance from the ground with the II-900. So unconventional, but a neat application. So robotics, I'm gonna breeze through these because I want to make sure there's time for questions. Cool example, just the suction cups on these pick and place machines, identifying which one needs to be fixed instead of just replacing all of them because it's not working properly. I mentioned natural gas leaks earlier and argon leaks, just an example of that from a storage tank. This argon's getting piped into a facility for part of the production process. Pretty big expense here for argon, and so to identify those leaks is a significant savings. There was actually 2 more leaks between here and where it entered the production process. And then finally, steam leaks, not energy savings from a compressed air standpoint, but still considerable energy savings because it takes a lot of energy to create steam. So for those applications where you've got steam traps or steam lines running that are way overhead, like in this case, a pretty unique way to be able to identify areas to go make a fix and save some money there. All right, sorry for being so quick there, but I just wanted to get the wheels turning for you. Dustin, with the last couple of minutes, are there any questions that popped up in the chat box?
Yes, indeed. First question, what is the Fluke suggested or recommended frequency range to for identifying compressed gas leaks?
Justin, you want to take that? I typically set it between 18 and 24 kilohertz to start, and then I scan up if there's ambient noise. But I'll let Justin share his expertise there.
I usually set it at about 25 to 40. and start there and see what I can find. And really, a lot of them, 80–90%, you won't even have to change it from there.
Awesome. Thank you for that. Are there any industrial environments where the ambient sound washes out the target signal?
You know, I have not experienced that. It's kind of incredible the first few times that you're in an environment where it's so loud and there's so many different sounds, and yet it all gets filtered out. So yeah, that's a good question. I haven't run across one. Have you, Adam, had it wash out at all?
No, I mean I've had them appear washed out on the screen until I adjusted and found that right frequency band where I was eliminating the ambient sound. So there hasn't been a situation where I haven't been able to adjust the tool in order to isolate the frequency band where a particular leak was coming from.
Yeah.
Excellent. And then someone asked if they can get a recording of this presentation. I just kind of want to address that, that there was a technical difficulty, I guess, that I was not aware of. Nobody was getting these recordings. So I did finally get the emails that everybody had been sending me over the last few weeks, asking for recordings and things like that. I just started getting them this morning. So I will be following up with each one of you on your questions, and you should get the recording of this presentation shortly after we end this webinar. All right. What are the most expensive, what are the most expensive leaks you've seen?
Well, I mean, I've seen leaks that are, you can put your hand there and it's blowing very, very hard. So it's thousands of dollars a year.
Yeah.
There is a point where if it's just blowing out, it's not going to create the same type of sound signature. If it's so large like that, then our estimating tool won't drive that cost up any higher. There is a limit.
Okay. Yeah, well, I know we are over time here, and there are no further questions. So definitely appreciate your assistance here, Justin and Adam. Thank you guys for your time. Everybody out there, thank you for joining. I know most of you have been to all three of them. Hopefully you learned a lot. We'll be setting some more up here in the near future. Feel free to reach out to us if you have any questions, and enjoy your weekend. Stay safe. Stay sane.